Standard 6.11, ratios and proportions. First of all, we have this dot plot here that's showing all of these different categories of favorite t-shirt colors for teenage girls in this survey. So the first question says for every 7 white t-shirts they manufacture, there should be 4 yellow t-shirts. So I just want to know the ratio of white to yellow. So the ratio of white is going to be 7, and then there are 4 yellow. The ratio of the number of girls who like white to the number of girls who like colored t-shirts. So white is 7, but we have to count up how many of them are not white to find colored. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 total colored shirts. The last one says 3 out of every 26 t-shirts they manufacture should be orange. The ratio of the number of orange t-shirts to the number of t-shirts. So if there are 3 orange and 26 total, that's how we're going to write it. It is 3 to 26. The other ways you could write these ratios is as a fraction, so you could write it as 7 to 4 if I'm looking at the first one, or you can use words to just say it's 7 to 4. Those are the ways you can write the ratio. Alright, this one wants me to fill out the missing values in the table. And then we're going to have to write an equation. So if I'm talking about miles and hours here, we're just going to kind of look at what we have information for both things on. I'm going to wait until my class can handle this. Where should your attention be right now? Thank you. Keep it there. If I'm talking about 3 hours and 21 miles, then I'm just going to fill in here. I can tell that there's a gap here, so this is going to have to be 2, because it would be 1, 2, 3. And then here, this would be 4. And if it's 2 hours for 14 miles, I know that 1 hour would have to be 7 miles. Then I know that it's counting up by 7s, or it's multiplying by 7. So 2 times 7 is 14, 3 times 7 is 21, 4 times 7 is 28, and 5 times 7 is 35. So I've filled out the missing information in the table. Now I want to write an equation that relates miles to hours. So I'm going to say let m equal miles. And then I'm going to say let h equal hours. And I know that every hour is going to be 7 miles. So h equals 7 times m. Oops, I did that backwards. Hours can equal 1/7 of m, or m can equal 7h. Because if I put a 1 in for hours here, I would have 7 times hours, which would be 7, and that would give me miles. If I put in a 2 for hours, I would have 7 times 2, which is 14, and 14 would give me miles. I'm going to graph these on this chart here. So I have to figure out what depends on the other one. So do miles depend on hours, or hours depend on miles? And I know that miles depend on hours. So miles are going to go this way. Hours are going to go this way. Now, if I'm graphing this, I know that if we went 1 hour, so I'm going to label these by 1s down here. I'm just going to put a few of them. And then I'm going to go ahead and count my miles by 7, because it's going to be really easy to graph it that way. So after 1 hour, I've gone 7 miles. After 2, I've gone 14. 3 is 21. And you can see the way my line is going to go. I'm just going to connect these points. And it's going to keep going up at that rate. It says to identify the unit rate in the table, the graph, and the equation by putting a box around it or pointing to it with an arrow. So the unit rate here, after I go 1 hour, that's my unit rate because I'm talking about 1. So this is where it would be on the table. Here is where it would be on the chart. After 1 hour, I've gone 7 miles. And in the equation, It's right here. It's what I am multiplying the h by. It's my coefficient. This is another unit rate one. We have to figure out in this table which juice is going to be the juiciest. The easiest way to do this is to find a rate and we can compare. If you look at this one right here, I'm going to go ahead and do juice concentrate to total. It's going to be 2 to 14. If I wanted a unit rate, that would be 1 to 7. And I'm going to just use those two numbers on all of these. So this is a 6 to 21. If I wanted a unit rate, I would have to divide both of these by 6. There are a lot of ways to do this problem, but this happens to be the way I chose today. So then if I took 21 and divided it by 6, that's what this is telling me to do. It would go in 3 whole times, and I would have 4 left over, so I'd have 4/6. I'm going to simplify that to 2/3. So it would be 1 to every 3 2/3 total. And then I'm going to take this same one here. And actually I can kind of compare the 6 to 21 and the 6 to 22. And I know that this one's going to be just a little bit juicier than this one is. And this one's not very juicy at all because I've got 7 total for every 1 juice concentrate. So this is going to be the juiciest. This will be next. And this will be the next one. Unit rate is a really good way to find these. But there's so many other different things in this table that you could figure it out by comparing things that are similar. If you look, some of them are the same on both tables, and then you can kind of eliminate that one. Kind of like this we did on this one. 6 here, but this one has 22 total, and this one has 21, so we knew this one was juicier. So if you can find things to compare, it might help. Mitch needs to purchase soft drinks for a staff party. He's trying to figure out if it's cheaper to buy the 12-pack of soda or the 20-pack of soda. The 12-pack costs $3.99 and the 20-pack costs $5.48. Which should Mitch choose and why? So when you set these up, you want to think about the way you say it. Would you say cost per soda or soda per cost? Hopefully you know that you would say cost per soda. So that's the way you're going to write it down. So if the cost is $3.99 for a 12-pack, I'm going to write $3.99 for every 12. And then the other one is going to be $5.48 for every 20. Now all I'm doing is dividing to find a unit rate, because unit rate is going to be when I just divide the numerator by denominator, because that will tell me how much it costs for each pop. So if I'm here, I'm going to go ahead and do $3.99 divided by 12. It's going to go in 3 times. I'm going to do my little shortcut here. And I would have 39 left over. It would go 3 times again. And then I would have 3 left over. It's just going to keep going. So that means it's 33.3 cents per soda. I found my unit for this one. Now I'm going to do the same thing on this guy. And it's $5.48 for every 20. So I'm going to take $5.48 and divide it by 20. 20 goes into 54 2 times. I would have 14 left over. I'm going to have to bring down the 8. 20 is going to go into 148 7 times. And I would have 8 left over. Oops. I could bring down another 0. And it'll go in 4 times. So this is going to be 27.4 cents per pop. So my better deal is this one. And if I had to write a good reason why, I would say this is a better deal. Because a 20-pack is a better deal because it's 27.4 cents per pop, and the other one is 33.3 cents per pop. One math student, John, can solve these 6 math problems in 20 minutes, while the other student, Joaquin, can solve them at a rate of 1 problem per 4 minutes. Who works faster? Same thing, I'm going to set it up problems per minute because that's the way I would say it. That would make the most sense. So if I have problems per minute, I have John, and he solves 6 in 20 minutes. And Joaquin solves 1 in 4 minutes. And you notice I put the problems on the top and the minutes on the bottom because I want to know problems per minute. If I take 6 and divide it by 20, I'm going to have to put a decimal here and a 0. It's going to go into 60 times, but it'll go into 63 times. So he's solving 3/10 of a problem each minute. Joaquin, hopefully you know that 1/4 is the same as 0.25. So he's solving 0.25 problems per minute. And if you're thinking about it, 3/10 is bigger than 25/100. So this is more, this is faster. So John is solving faster. It's saying show how you compared the two answers. This would be a perfectly good way to say it. John solves 3/10 of a problem each minute. Joaquin only solves 25/100 of a problem each minute. So John is faster. This table. So many of you did not like it the first time around. You know a lot of information without thinking so much, especially in this column right here. If the percent saved is 20, you know that you paid 80. This has to total 100%. So if you saved 25%, that means you paid 75%. This time, if you paid 90%, that means you saved 10. If you saved 40, you paid 60. If you saved 80, you paid 20. So this whole column you should be able to fill out if you know one of the sets of information. This one, I don't know any, so I'm going to have to wait on that one. Some of these you should also be able to figure out the other one. If the sale price was $800 and you paid 80%, that means that you saved, because these two are going to go together, that means you saved $200. Which means that the original price would have been $1,000. A lot of these, however, you can't just know off the top of your head. You will have to set up your part to whole ratio. So I'm going to go ahead and start with the percent. I always know that the whole percent is 100. And I'm just going to pick one of these or we'll be here for a long time. So I'm going to do this one right here. So the total percent is 100, and I know that the sale price was $51.60. I have to decide, does that match with what I saved or what I paid? And I know that the sale price is going to be what I paid. So I have to make sure I match these up. So 60% is the part that I paid for, and the actual number I paid for was $51.60. What I don't know is what the original price was. This is what I'm solving for. I'm going to call it X. Now I can use my cross multiply. Remember, the only time you can use cross products is if this says equal. Please do not try to do cross products if it says multiply, because you only multiply numerators and denominators if it says multiply. If it says equal, you can use cross products. So now I have 60 times X, which is 60X. And that equals 5,001. And basically, if I multiply by 100, it's just sliding my decimals 2 times. So it's going to be 5160. Now I can just divide both of these by 60. When I do that, 60 divided by 60 is just 1x. That's what I was hoping for. These zeros can cancel that. It's going to make my job a little bit easier. Because now I just have 516 divided by 6. I'm going to move it over here because I'm running out of room. 516 divided by 6. 6 and 8 is 48. And 6 goes into 36 6 times. So that means that X is $86. And we put X over here. So that means our original price was $86. If we need to know what we saved, that means we saved 86 minus 5160. I'm going to have to put a couple decimals and some zeros here. So it should be 3440. Oops, I did something wrong. No, I didn't. 3440 is what I saved. And that makes sense because it's 40% off, which means it's almost half off, but not quite. So check to make sure that they make sense. I'm not going to go through the rest of them, but that's how you set up your part to whole. We're going to set up one more part to whole. So the Sparkling House Cleaning Company has cleaned 28 houses this week. If this number represents 40% of the total population, or the total number of houses they are contracted to clean, how many total houses will the company clean by the end of the week? So I'm going to start with a part to a whole. Look for percent here and numbers here. Make sure you guys are trying this too. I see a lot of people who think that this is just their time to do nothing. I'm trying to help you right now. Be writing things down. Wait, there's a lot of people that still don't have anything to write with. That's why I said you need to be taking notes. Okay, so the part is 40. The whole percent is always 100. They cleaned 28 houses this week. That is not how many total houses, because it asks how many total houses. So I know that this is going to be the total. And 28 is how many they have already cleaned. Now you should be working a little bit ahead of me because you should know where to go from here. If I have an equal sign in the middle, I know that I'm going to be cross multiplying. I can only do it if there's an equal sign. Now I have 40x equals 28 times 100 is 2800. Now in order to get x by itself, I have to do the opposite operation. It's being multiplied right now, so I'm going to divide it by 40. Now x is going to equal, over here if I have 2800 divided by 40, I know that those zeros are just going to cancel that place value out. So now I have 280 divided by 4. 4 goes into 28 7 times. And I'm going to bring down the 0. 4 does not go into 0 at all. I have to put a 0 here, otherwise it's not going to have something above every place value. So x equals 70. Now you have to go back up and see, what did you set x equal to? So x was what I was looking for, which is the total houses cleaned. So I'm going to say 40 houses that week. And that is the end of standard 6.1.1, ratio and proportion, and you thought it was hard.